In today's lesson, we're covering enthalpy and thermochemical equations. Make sure to have out your notes. The enthalpy, or H of a substance, represents the heat content of the material for substances that occur at constant pressure. The change in enthalpy, or delta H, is the difference in heat content between the products and the reactants of a chemical reaction. So delta H will always be equal to products minus reactants. So if heat's flowing out of the system, okay, so here's my system. I have a person in there. And heat is flowing out. That means it's exiting, right? This is an exothermic reaction. And your delta H will be negative. On the other hand, if you take that same system and you have heat going into the system, it's endothermic, and your delta H is positive. It says a thermochemical equation is a chemical equation that gives information about the heat of the reaction. Delta H is also known as the heat of reaction. Now, we've gone through a lot of reactions in this class. Thermochemical equations take into consideration heat. That's what separates it from other types of equations. Okay? When you think of thermo, hopefully you think of thermometer. Okay? Thermometer measures your temperature. Okay? So thermochemical equations will have heat in them as well. Okay? So let's look at our first example. We have the synthesis of water. Okay, so we've got hydrogen and oxygen coming together to form water. Notice that heat, measured in kilojoules, is on the product side of this thermochemical equation. Now, the fact that it's on the product side means something. It means that heat has been released. Okay, it says, we know this reaction is exothermic because delta H value appears on the product side. Heat is released overall. Okay. We also know because over here it tells me the delta H is negative. If you see a delta H that's negative, we said it's exo. Okay. So if you're calculating delta H and you get a negative, you read that as 572 kilojoules of energy is released by the minus sign, meaning it's exothermic. That's similar to looking at a thermochemical equation and seeing heat on the product side. That also means heat is released. Okay, so let's look at the opposite reaction. Okay, now we have the decomposition of water. Heat is written on the reactant side. Okay, this tells me that heat has been absorbed. If heat's absorbed, it's endothermic. Okay, so the fact that heat is on the reactant side tells me it's endothermic. Just like if we're calculating delta H and I get a positive value, I know it's endothermic. So we know that this reaction is endothermic because the delta H value appears on the reactant side. Heat is absorbed overall. Okay, so in conclusion, if heat's written on the product side, exothermic. Heat's written on the reactant side, endothermic. Okay. Heat of a reaction can be calculated by the following formula. Delta H equals the products minus reactants. Use the delta HF values provided in the notes on the next page. Always know that it's products minus reactants. It says multiply the delta HF value for a compound by its coefficient in the balanced equation. Okay, put a star for these two. This is what kids always forget to do, is to multiply the coefficients. Okay. Also, the next one says delta HF for an element in its standard state is always 0. Okay, so for example, if you have an element like hydrogen, for example, it's diatomic, meaning it can't be alone. There's two of them together at all times. This is still just an element. So its delta HF would be 0. Okay? So let's practice. It says first you're going to find the heat of the reaction by subtracting products minus reactants. And you're going to state whether the reaction is exothermic or endothermic. Then write the delta H value on the correct side of the equation. Okay. So what you're going to do is you're going to look on the next page for the values of all of your reactants and products. Okay, my first reactant is calcium oxide. Okay, so if I go to the next page, okay, tables of heat formations. Now, I'm looking for calcium oxide, and I find it. It's right here. And it says in my table that's negative 635.5. Okay, so I'm going to go back to my reaction, and basically I'm going to calculate a total for my reactant side. Okay, so I have negative 635.5 plus, just like in your equation, you add water. Okay, so I'm going to look up water on the next page, and I find that in liquid form, it's worth negative 285.8. So I'm going to get a total for my reactant side, which is negative 921.3. Now I'm going to get a total for my product side. Calcium hydroxide, if I look it up, it's negative 986.6. Okay. From this information of my totals, I can calculate delta H. Okay. We said delta H is equal to product minus reactant. So we know the product is negative 986.6 minus the reactant, which is negative 921.3. Now I have a problem. I'm subtracting a negative. When you subtract a negative, you're really adding. So what I'm really doing is negative 986.6 plus 921.3. You cannot subtract a negative. It's really adding. So what I get for my delta H is equal to negative 65.3 kilojoules. My delta H is negative. What does that tell me? This is exothermic. So how do I represent something being exothermic in the equation? It goes on the product side. Okay? So your final answer is really including this in your reaction. So plus 65.3 kilojoules needs to be on the product side to indicate exothermic. Okay? All right, let's try number 2, and then we'll be done with our tutorial for today. N2 plus 2O2 yields 2 molecules of nitrogen dioxide. Okay? What's the value of nitrogen on here? Well, remember one of our rules said that if it's just an element in its standard state, it's always worth 0. Oxygen's also just an element, so it's worth 0 too, as well. However, nitrogen dioxide does have a value, okay, and that's an arrow. It looks like a 7. Okay. Nitrogen dioxide is worth 33.9. Now remember, another one of our rules said you had to multiply by coefficients. We got lucky in example 1 because our coefficients were all ones. But here we have a coefficient of 2, so we have to multiply. So I have a total of 0 for my reactants and a total of 67.8 for my products. I'm going to go calculate delta H. Delta H is equal to products minus reactants. So I have 67.8 minus 0. And I get 67.8 for my answer. This is positive 67.8 kilojoules. Because my delta H is positive, this is endothermic. So how do I represent this in my equation? I represent it by writing it on the reactant side. So I'm going to put 67.8 kilojoules plus all of my other reactants. Okay, so because it's endothermic, it goes on the reactant side. When it's exothermic, it goes on the product side.